Hi there, today I'm going to have a look at pot. Yeah, pot man. No, not that type of pot. Don't you know you get arrested for smoking that dope? Dope? You what? No, actually what we're talking about is pots, potentiometers, potentiometers, variable resistors. That's what I'm going to be talking about today. Different pots. These are quite chunky ones. Usually you might see them being used for, I don't know, volume control or other things in different circuits. So let's have a look and see what we can do with them. Okay, so here we've got some pots, potentiometers, potentiometers, how you ever want to do it. They're variable resistors, call them what you like. They come in quite a few guises. I've just got a few here. I mean, I've got these wired up because I've been using them, testing them in a circuit. A couple here. I've got a 4.7. Don't know if anybody can... Oh, I can never get this right. Anyway, that's a 4.7 or 4,700 ohm resistor, potentiometer, sorry, pot. I'm just going to call them pot. That's the easiest way, pot. This is a 10k. This one is a 250k. And this one, a bit of an oddity, this is, I believe, a 500k joule pot. I'll explain this one in a bit. It's a bit of an oddity, that one. Also get these little ones, little trimmer pots. These tiny little blue ones. Things like this one as well, slightly different casing, still just a trimmer pot in all sorts of values. This is a 1k, tiny little 1k trimmer pot, and this thing, again, I have no idea if this will focus on it, probably not. I don't know. Let's try using the zoom because it tends to work better that way. If you can see that, it says on it 10 meg. That's 10 mega ohm of resistance in a trimmer pot. Can't think of any specific reason why on earth I would ever need a 10 meg ohm trim pot. There you go. The other thing you notice about pots is you've got B. This is denoted with a B at the beginning, whereas this one has got an A on it. Now that is the difference between a linear pot and a logarithmic pot. Just to demonstrate that, let's find, what's this one? This is let's do the 10k pot, be easier. Let's get the meter on. If I connect across the two terminals end to end, it'll tell me that I've got 10k. Well, there's the other thing about pots as well. They've got a tolerance. Some you might find they've got a tolerance of 5%, but it's more likely to be 10%, and you've even got pots that have got a tolerance of 20%. So that's a big difference between what it says on the label and what you actually get. And I see if I turn the knob, nothing happens because I'm connecting across the whole of the pot. I suppose I should draw it out really, shouldn't I, as to what we've got there. But if I connect to the centre, between one of the pins in the centre, at the moment I've got full the full resistance. If I turn it halfway, I get about half the resistance. Turn it all the way, no resistance, because it's moving up the scale linearly. Whereas this one is a 250k pot. So if I measure across, turn the range up, I get, again, see there's a tolerance there, 10 or 20%, 231k ohms. And obviously it's on either end, so moving the the knob won't change anything. So obviously if I connect to the centre though, I still have my 232, but as I start to turn this and it starts going down, it doesn't go down, so that's there, it doesn't go down gradually. At halfway point I'm still at 188, so it's not linear. This is a logarithmic pot, so the movement is on a logarithmic scale, so you get a small amount of change and that change gets bigger and bigger and bigger, or you get a big amount of change and it gets smaller and smaller depending on how the pot is and which way you wire it up. So there you go, at halfway point 188. It's not 125, okay, because that would be half 250. It's at 188 because it's a logarithmic pot. Now let's have a quick drawing. Pots are very good and very useful because, go back to the old voltage divider. You've got a value there, that's R1, R2, you put whatever in, plus volts, 0 volts, output, and you know you want a particular voltage on here, so voltage 1 you want to be a certain voltage. Use the voltage divider, you get what you want there. But because of tolerances, you find that sometimes you don't quite get what you want there, and you've got to work within predefined values, so you might not have the right values to get your output. Whereas if you've got a pot, of which, and this is how I draw it, other people might draw it slightly differently, that's the wiper, the slider within there. So effectively what you've got is just a voltage divider. It's like having two resistors, only that bit is the wiper part and it moves up and down against the whole resistance. So effectively it's a bit like having a voltage divider, and you can move the knob to decide exactly where you want it to come out at. That's pretty simple, like I say. Plus volts, 0 volts, they are 1, and output for your voltage one coming out there. Brilliant. What more can you say about that? That's just dead simple, because as well you can turn your pot and trim it to exactly where you want it to be without having to fuss and mess about. So you've got other ones, these tiny little trim pots. So I'll mention that in a minute. Let's put it on here. You can use them also if you wanted to put them, let's say, in parallel with a circuit. That's what we'll use. Let's use this one. It's the 4K7. So let's have a look at the resistance of, I don't know, let's choose this resistor. This is a 3.88, probably rated as 3 and 3.9. I expect that's what it is. Orange, white, black, is it? Yeah, it's going to be I bet it's meant to be a 3.9K. So if we put that, get that in there, and connect across there. Now remember, we've now got two resistors in parallel, so when this is all the way down I've got nothing, so that's said 3.9, and this is a 4K7, 4.7K. So as I turn it up, I'll have whatever the resistance would be for these two in parallel, which as we know is less than the smallest resistance. In this case, when it's all the way up, I've got 2.16 k ohm, 2k2 virtually, but I can change that, I can trim that down to whatever I might need to change it to. 10 meg. My multimeter won't read 10 meg, it won't get anywhere near it, it only goes up to 2 meg I think. But if I take that 10 meg and I shove this, which I know to be a 1 meg resistor, there you go, 1 meg ohm resistor, and I shove it across this big ass trim pot. 10 meg. Who the hell uses 10 meg for anything? I now have just under 1 meg, but I can trim that, I can change that from just under about 900k down all the way down to basically nothing because of the way it's wired up. It's almost like a really coarse adjustment in it, because the resistance is just so high. But you could use a smaller one like this one. This is a 1k pot. Let's just see if we can jam that in there. Doing exactly the same thing here, only with a 1k pot. So effectively we've got resistors in parallel, so I can go from 500 ohms and trim it all the way down to 0. But the other thing I could do is I could put it in series with 2 resistors. So I've got let's get this in there, that's the centre point, and that one is from the outer edge from the one side. So what I'm actually doing is, get a bit of paper, what I'm doing here is I'm taking a resistor, trimmer, not enough room here, and a resistor. I haven't done that at all, that's rubbish, that's total, don't listen to me. What I've done is I've taken a resistor and then that has connected to the centre point of that pot, and then it comes through on the other side. So that's what I've got. So we're trimming this centre point. That's not connected anywhere. So by trimming that centre point, we have about 2k there, but I can trim that up. I could, if I was to put this in the centre and I was to actually calculate what resistors I needed, I could say I need a specific resistance in there, and because you're working with set values, you put the trimmer in the middle, and it could be very small. See, I can take this all the way up to about 3k because I got to 1k. These are all 1k resistance, but I could put, say, like 100 ohm resistance in there. Choose the correct resistors that I need here and here, and then use the 100 ohm pot just to trim to put it exactly where I want, so I get exactly the right resistance. So there you go, pots. I mean, haven't done any maths because basically the maths is just Ohm's law, either in series or parallel, or like a voltage divider, and they can be used all over the place. Especially stuff like this, they tend to find these used in guitars. 250 ohms, and 500 ohms are classic guitar values. What did I do with that other part? Oh yeah, this one, this nutty little thing. This is a dual gang, but this one is a 500 ohm, no, 500k. Now, if I connect between there and there, I got 500 odd, or whatever it is, and on the bottom one, I connect between there and there, I've got 500. Now if I connect between there and the centre pin, and I turn it, this is in the centre point, so as it turns, as it gets to the centre, there's almost like a click as it stops at that point, so you know where the centre point is. If I turn it from, as it were, from 0 up to the centre point, on the bottom pot doesn't do anything, but as I go past it, it then trims it, or up or down, depends on where you want to connect it. But on the upper ring, between the 0 and the midpoint, again it does nothing. It goes from full to 0, but then as you take it past into the second half, it doesn't do anything. So this pot is a bit of an odd pot, and I bought it to go in a guitar to control the volume across a tapped humbucker in a particular way. So it's a bit of a specialist, but as you see, you can get specialist pots that do particular jobs that depending on what you want to do. So there you go, pots, potentiometers, potometers, variable resistors, however you want to phrase it. There are lots of different types, lots of different applications: volume pots, tone pots, control pots for inputs or outputs, guitars, musical instruments, whatever you like, pots. Lots of them, and very useful in a circuit. So there you go, that's pot, potentiometers, variable resistors for you. Just a quick overview, no maths involved because it's all just basically resistance in parallel or in series, and that's pretty simple on its own, isn't it? Pots, there you go, used all over the place. So if you like this video, give us a like, subscribe, all comments are welcome, and I'll catch you next time.